Hello, I'm Dave Thomas, and in this short screencast I want to show you just the essence of the Elixir language. I don't have time to go into all the details, but if you go to the page linked at the end of the screencast, you'll see a 30-minute long introduction that goes into a lot more detail. But just for now, I'd like to show you some cool stuff. I'm going to start off by defining the map function. You know the map function. It's the one that takes a collection and a function, and it applies that function to each element in the collection and returns the result as a list. So how do we define that in Elixir? Well, let's start off by defining a module. We'll call it C, just for collections. And inside that module, we're going to define our map function. Now, the first thing we'll do is think, what's the terminating condition of our map? Well, if we give it the empty list, then it's going to return an empty list, because mapping an empty list returns nothing. So we'll type that in first. Now we have the more general case, a list that has content. To do that, we're going to have to say we want to map a list that has a head and a tail. The head is the first element, the tail is the rest. And again, we pass in the function, and the result of this is a new list where the head is the result of applying the function to the original list's head, and the tail is the mapping of the tail to a new list. So you can see the recursion here. It's going to come back and do map until the list is empty. So does it work? Well, let's try it. We'll go down the bottom here and we'll type in a call to our c.map function. We'll pass in the list 1, 2, 3, 4, 5, and the function will pass in. It'll take each element in the list and it will multiply by itself. It'll square it, and there we go. We've actually got the result. Now, we have a warning here about an unused variable, func. If we go back up to the line that it references, you'll see that on the empty list, the function indeed is not used because there's an empty list. To tell Elixir that we're not using that function, we just put an underscore in front of the name. Run it again, and the warning goes away. Now, Elixir has a shortcut for simple functions like this. Rather than typing out the entire function definition, I can use this ampersand notation. Here it says, generate a function that multiplies its first argument by its second argument. And you see we get the same result. So that's a simple implementation of map. Now let's make it more complex. Let's run a version of map that actually runs every single element in a separate process. So each element will be converted in its own process. The advantage of this, obviously, is that it will be able to take advantage of all the cores and all the processors on your machine. If you have an 8-core machine, then this map will run 8 calculations at the same time. That's pretty cool. So let's see how that works. We're going to write a function called pmap. Just like map, it takes a collection and a function. But what it's going to do is take that collection and split it apart and run one process for each element in that collection. It's going to pass down to that process the element and the function to run. And it's also going to tell that process who to respond to with the result, and that's going to be ourselves. So the next phase is that we're going to do a collection where we go through each of the processes in turn and say, what value did you calculate? And we'll build those values into our resulting list. Now, when I think about functional programming, I think of it in terms of transformations. A function is something that takes a value and transforms it into a new value. So our parallel map function is the same. It takes a collection of elements, and the first thing it does is go off and spawn a bunch of processes. So it's effectively turning that collection into a collection of PIDs. And then given that collection of PIDs, it's going to transform that into a set of results by asking each process in turn to give its value. So let's think of this in terms of transformation when we do the coding. So we're going to write a new method, a new function called pmap. It's going to take a collection and a function. Now remember our transformation. That's just exactly what we're going to write as the body of this function. So we have our collection. We're going to transform it by creating a bunch of processes. We're going to spawn a bunch of children. And we're going to tell those children what function to run by passing that function through to them as a parameter. Well, that results in a set of PIDs, and now we're going to go and collect the results from those PIDs by transforming again through collect results. And that's the essence of what we want to do. So now let's go ahead and write our spawn children function. It takes the collection and it takes a function. And all it has to do is to go through, and for every element in that collection, it needs to create a new subprocess using the built-in function spawn. And so we run a map on that collection. We're going to take each element in turn and pass that element to spawn. We're using the variant of spawn where we pass the module name, the name of the function, and then the arguments to pass to that function. The parameters we're passing are the element itself, the function to be applied to that element, and then our own process ID, self. That's how it knows who to respond to. So our child function takes those three arguments, calculates the results of running the function on the element, and then packages up those results along with its own PID and sends it back to its parent. So when we say parent, and then an arrow, and then the tuple, self, and the result of the function, what's going to happen is that tuple gets sent back to the parent. So the last thing to do is to write the function that collects the results. It's passed a list of PIDs. So it's going to use the map function on that list to extract them PID at a time. And for each PID, it's going to use an Elixir receive block to receive a message from that PID. Now receive takes a list of patterns and the code to execute if that pattern matches an incoming message. In our case, there's only one pattern that we're matching, and that's a tuple where the first element is the PID we're interested in and the second element is the value. When we find that message, we extract the value and return it back from the function so that that becomes the next element in the result list. Process the entire list of PIDs that way, and we end up with a list of mapped values. Scroll down to the bottom of our program and change the call to map to a call to pmap, and it works. We're now running each one of those square operations in a separate process. The cool thing is that that's totally transparent to the code that calls it. So that's been a very small taste of the Elixir language. I've shown you some of the functional programming paradigms, some of the concurrency paradigms, and I've also shown you that we have a rock-solid environment here to run code with good error checking and decent performance. But why should you care? Well, the reality is that object orientation is great for writing single-threaded code. But the second you start trying to worry about multiple processes or multiple threads, you're in trouble. You have shared state, or you have to worry about creating locks or synchronization points of some kind. Elixir bypasses that. The functional model with immutable data means you don't have to worry so much about shared state. And the Erlang VM that it runs on allows you to be concurrent. It allows you to be seriously concurrent. We can run hundreds of thousands of processes on a small machine, and it doesn't even break a sweat. It's a different way of thinking about coding. So, if you have the time, I'd encourage you to go to elixirlang.org and have a look at their information there. And maybe you want to have a look at the book I've just written on Elixir at pragprog.com/titles/elixir. And please feel free to contact me at @pragdave or #pragdave or dave@pragprog.com. Either way, just remember to make it fun. Thank you for listening.